Hey guys, today we are going to talk about the principles of steel design and its design philosophies. These are actually applicable to other procedures, uh, including reinforced concrete design. So let's try to define first some terms here in order for us to understand the meaning of the different philosophies involved in the steel design procedure. So first, design philosophy or philosophy. Philosophies are a system of principles used as guidelines in providing levels of safety. So when we talk of philosophy in design, we simply uh, refer to the idea, the principles, the fundamental guidelines for us to be able to provide a safe and sound structural design, particularly in steel. So for the limit state term, we refer to this condition in which a structure becomes unfit for service. So there are two types of limit state condition. The first one is the strength, and the second one is serviceability. So it's not complete to consider only the strength condition when we talk of safety in design, as far as the limit state is concerned, but also the serviceability aspect of it. So for the strength limit state, we define this condition, which is actually accounted for and manifested by the probable collapse of a structure or any part of it. And for serviceability limit state, this is the condition in which there is disruption on the functionality or use of the structure. So in summary, a limit state design methodology is simply a procedure wherein a structure or its members are arranged and proportioned so that no applicable limit state condition is exceeded when subjected to all appropriate load combinations. So to wrap this up, these terms here are very important as we go along the study of the principles of steel design, and they are defined in a way that we only need to establish the important keywords for us to understand, okay, the meaning of it. Okay, so again, philosophy simply are the system of principles that are used. Okay, the limit state is simply a condition in which your structure becomes unfit. And we have two types of limit state condition. The first one is the strength and the serviceability limit state, for which the strength refers to the collapse limit of your structure, while your serviceability refers to the functional limit of your structure. Okay, example of a strength limit state will be given to you later, and examples of serviceability limit states are deflection, vibration, and cracking. So for the process involved in the determination of the limit state, or sorry, the process involved in undergoing a limit state design procedure, we have basically three steps. The first one is to determine what potential limit state or limit states are. Okay, so this can be one, two, or more than two uh, limit state. Okay, and the first thing to do is to determine potentially, what are those limit state? The engineer has the obligation and responsibility of looking into those potential limit state in order of priority. And for number two, that we determine the acceptable levels of safety. So here again, the engineer will provide a margin of safety, a level of safety that would assure that that your structure will perform soundly against possible loads uh, and occurrences of all the limit states. And of course, after these two steps, we need to perform the actual analysis and design based on the principles we have learned on the theory of structures or structural mechanics. For the specific methodology that we use in this limit state design procedure, we have actually, in general, three methodology. The first one is the AST, LRFD, and the limit state or the limit design or the plastic design methodology. So AST, LRFD are acronyms of allowable stress design and load resistance factor design, respectively. So limit design involves the plastic analysis or the inelastic analysis beyond the elastic range, and there are a lot of considerations given to this. So these are advanced procedures in design, and these are actually shall I say elementary procedures in design. Okay, so for the ASD and LRFD, this is better known as the WSD on concrete and USD in concrete. Okay, so wherein this is based on the elastic theory, and this is based on the inelastic theory. The limit state design is beyond the inelastic range, which is called the plastic range as far as steel design is concerned. So take note that the ASD and LRFD differ primarily only on the provisions of the factor of safety given to it, and as far as the strength limit state and the serviceability limit state, they are just the same. And of course, for a basic safety criterion, we can define that always for a safe design, the resistance must always be greater or equal to the load, that is R greater or equal to Q, wherein the loads here refers to not only the actual load but also the load effects, including that of shrinkage, temperature, creep, etc. So for the factor of safety, always is measured by simply dividing the resistance over the load, and that is indicated by the equation omega greater or equal to R over Q in general. So basically the principle of design specifically in steel is actually made and considered on this premise, and the specific of such methodology will be discussed on our next video. Thank you very much.